So, thank you so much for being here. This is Tora Johnson speaking on climate change from the University of Maine at Machias. Welcome, Tora.
Thank you. Can everybody hear me okay? Everybody? Okay, great. Yay! I'm a teacher, so I'm used to saying, okay, can you hear me? I'm Tora Johnson. I'm the director of the Geographic Information Systems Laboratory and Service Center at the University of Maine at Machias. And I'm going to be talking with you today about a project that was part of a larger project called Grow Washington a Rustic, which I'll describe here in a moment. First, I want to explain a little bit about our program. So at UMM, we have a number of academic programs in geographic information systems. We specialize in applied environmental GIS and decision support, meaning we look at how we can use the tools of geographic information and analysis and visualization to support people who are trying to make difficult decisions. And these days, virtually every decision about any environmental resource is a difficult one, and it's particularly important to our region. As we've already heard, we don't have a lot of economic resources in Downeast, Maine, and our organizations and our governmental units tend to be very small. Even the businesses tend to be very small. So the capacity to grapple with difficult decisions is limited, and so we specialize in figuring out ways to add that capacity to the region. And the way we operate and do this work is that our students are engaged in my research and in projects that come into the service center through grant-funded work. So we've had a series of grants, beginning with a grant from the Maine Coastal Program that started the program, I think it was in 2004 or 5, that started, I think it's 2005, started the service center, and grants large and small. Students and student interns and recent graduates do the work in the projects that we do, and they're aimed at raising capacity in the region. So the project that I'm going to be talking with you about was part of Grow Washington Rustic. It was a regional planning initiative aimed at job creation, modern infrastructure, and healthy, affordable communities. It was funded by the U.S. Housing and Urban Development Agency, HUD, and involved both Washington County and Aroostook County. The UMM GIS lab provided GIS services for the Washington County portion of the project. And the project has a dozen initiatives. We're going to talk specifically about the Climate Change and Infrastructure Resilience Initiative. The GIS work, I should say, just because I'm so proud of my students and the work that we did on this project, and as somebody who's interested in applied research, I see it as the highest form of praise in my area that we've received Project of the Year awards, both from the Maine Association of Planners and the Northern New England chapter of the American Planning Association. Thank you. I'm very proud of that. And we really had a dream team of students. It was a couple of classes of cohorts that went through the program through this project, and several of them have banked on this work and are now employed in the field. Some are still working for us, actually. Oh, there are some of them. So this is the list of students who participated over the 3-year project. It's one of the ways we're able to really, raise capacity in the region is by engaging these amazing students. And as you can imagine, employers really like it when they are done with the program and they say, oh, you were part of this award-winning project. Some of them have already made themselves indispensable to the people that they were doing their projects for and have been hired by them. The work, as I say, that we do looks at supporting decision-making in a complex world regarding natural resources. And so what we employ here is best practices. So it's informed by literature and research about how best to communicate about science and how best to communicate about risk and how best to communicate, get groups of people to communicate with each other. Even things like how do you resolve conflicts when they arise in these decision-making processes. So among the best practices that we use, we're always thinking about tools in hand. So it's easy to make a GIS map, but really it's better if you give somebody a tool that they can use, and you'll see that that was central to this project. One of the really critical things, since we work in a rural area, and this is true whether we're working with municipalities or conservation organizations or what have you, the information, the geographic information that we provide and that they can get out of our maps and map applications has to be at a useful scale, right? So much of the information that we have about global climate change is global and regional, is at a scale that we actually can't use. And you'll see some of the practices that we've used to work with that and sort of make science available in ways that it wasn't before. We also understand the importance of local knowledge and local priorities in terms of cost. And also, we know that GIS itself forms a big barrier. I'm sure some of you have banged your head against it yourselves. And so we need to lower those barriers, and that's a really critical element. We're always operating at the nexus between conservation and government. So municipalities and regional planners are critical decision makers with regard to conservation concerns. Okay, so what are we looking at in terms of climate change and how is it affecting Downeast Maine, coastal Maine in particular, which is really the focus of the work that we've been doing? Temperature has been rising over the course of this century, and that's true. It's slightly more on the coast of Maine. One of the major, most critical changes that we're concerned with is the increase in the amount of precipitation. And one of the most critical elements is how much more variable. We already have on the coast of Maine very variable amounts of precipitation, so the amount of rain that we get in one particular year goes up and down a lot, but it has become a lot more variable. You can measure that by looking at the standard deviation and measure the variability of the data across the past century. And you can see that we are looking at an increasing variability, and the width of that graph as it goes from left to right is a really important element. And we're seeing larger spikes in precipitation, and those are intermittently interrupted by drops in precipitation. And that's a really important thing to understand, both in terms of natural resource conservation and natural resource use in Downeast Maine. Things are changing. So through the Grow Washington Heuristic project, we've developed a countywide climate vulnerability assessment. You can get that assessment on the Grow Washington Heuristic website, which I'll repeat later. It's gro-wa.org. And it follows a statewide assessment that was done a few years back in 2011, looking at all of these elements. And one of the reasons I want to put this slide up is that if we're going to adapt to climate change in Washington County, we need to recognize we're very resource dependent. And virtually everything we see here, so agriculture and nature, et cetera, is really important, but our infrastructure is very much linked to natural resources because so much of it allows us to access natural resources, including roads and forests and wharves and working waterfront infrastructure, et cetera. So So for us, probably more than less rural parts of the state, all of these things are interrelated. And so there are even more overlaps between conservation and governmental interests. We're very concerned. I'm not going to talk a lot about climate mitigation, which is essentially, not putting quite so much carbon dioxide in the atmosphere. We're looking at adaptation. What can we do to adapt to the effects of climate change? So I'll let you go ahead and read the countywide climate vulnerability assessment, and as the town-specific ones come out for coastal towns, there'll be more information there. But I want to focus on one of the key things that we've done to look at how climate change might affect Downeast, Maine, and that is to look at the potential effects of storm surges and sea level rise. And adapting to more frequent and more intense storms is going to be increasingly something that we're going to need to do over the course of the coming century and beyond. And the other reason I wanted to show this to you, it's also really cool and awesome, but also it shows some of the best practices that we're using and the ways that we're approaching the problem. So just to be clear what I'm talking about when I talk about storm surge, it is the extra water that is pushed in, typically by, pretty much entirely by the wind, so it's wind-driven water. Remember that's a very important element. It's over and above the astronomical tide, so that the regular old tide that's caused by the sun and the moon is added to by whatever amount the storm surge is. And we have built a series of storm surge scenarios based on the output of the National Weather Service's Sea, Lake, and Overland Surges model, or SLOSH, which is the best acronym ever. And the SLOSH model is a really useful tool, and it has a couple of different outputs. We use sort of the worst case scenario sort of output, and we're working with some real-time prediction stuff now, but for right now, what we're talking about is a worst case sort of scenario. It is built, the storm track incidentally that you're looking at here is Irene, but it is built on the idea of a fictitious storm, but it's constructed from real tracks that have occurred. So it's a computer modeled storm, but it's from measured tracks. And this fictitious storm would make landfall with the eye on Penobscot Bay, which would put us to the east of the storm. And if you look here at the circulation patterns of the storm, if we're to the east of the storm here, it means the winds will be going from south to north. And since the glaciers scraped out all our long, skinny bays, that's a really important thing for us to know, that prevailing winds on that side of that storm would be coming from the south. And remember, the storm surge is wind-driven water, right? So it's pushing up those long, skinny bays, and you have a literal slosh effect at the heads of those bays. So in a lot of places where we've been doing these models, for instance, Cherryfield and Calais are places you wouldn't even think of as coastal towns, are vulnerable to storm surges with salt water, for instance, overtopping a dam that's meant to hold back fresh water in Calais. So, likely salt water in low-lying streets in Cherryfield. So this is some information that could be pretty useful if you want to do some planning for, say, Salmon Passage and wetlands and so forth. Okay, hurricanes, those never happen in Maine, right? The fact is that we frequently get winter storms with forces comparable to Category 1 and 2 hurricanes. And Hurricane Irene, there but for the grace of a few degrees go we. It came ashore as a Category 2. It dumped 11 inches of rain in Vermont in one day and absolutely devastated little tiny towns all over Vermont that look very much like little tiny towns in rural Maine. And now that wasn't a storm surge. Other places were impacted by the storm surges. But the point here is that we are vulnerable and will be increasingly vulnerable as the Atlantic Ocean warms. And so we're starting to understand that this is important. I'm going to show you some storm surge scenarios here in a minute. And the Category 2 storm, this is the worst case scenario, that comes ashore at mean tide, so low tide, or a middle tide, is equivalent to what used to be a 1% storm, so what they call a 100-year flood. What they're estimating by the end of the century, it'll be at least a 5% storm, so there'll be a five-fold increase in the frequency, they say. So a 20-year storm is what they're calling it. I'm going to breeze through this since I just got the 5-minute warning. I think I have less time because we started a little late. But one of the key things that made this possible is the LiDAR data that we now have, which allows us to model in 3 dimensions far better than we could. And I want to make a plug. We have only the strip of the coast, all along the coast of Maine. We have this data. We don't have it for the inland rivers. And so we are not able to do the kind of high precision modeling of flood scenarios in inland. And that's a really important element because not only do floods happen, they don't only happen on the coast. So we used the LiDAR to do something called downscaling. And this is one of those best practices that I told you about. So a lot of folks that we worked with had seen the National Weather Service's output from their slosh models, and this is what it looked like when overlaid on a map. So this is Machias Bay, and you can see that this is not nearly as useful as it could be, right? So this is an estimate of the surge height at that location, but it doesn't show you at all what would actually be flooded, right? And so we used the estimated surge and matched it with a high precision elevation data to look at exactly where would be inundated, and we'll look at some maps. And we did that for all the major bays, all the bays in Washington County. So I'm just going to go through some of the stuff we did, some of the results, so that you can see what it looks like. But we have interactive web-based maps for this purpose. I was going to show you those, but my server's crashed, so it'll be up, I promise, soon. So if you go to the GROA website and look through the climate stuff, you'll find links to these maps, and you can interact with them and look at different scenarios. We're looking at Category 2 mean tide scenario, downtown Machias. Here's Helen's, which just burned down, the wastewater treatment plant, and Main Street. This is the causeway, the dike, and you can see the floodgates, the tide gates here. So in this scenario, Category 2 mean tide, what was a 100-year flood will be a 20-year flood. Is the causeway is overtopped, and most of downtown is flooded. Here's that same scenario with 3 feet of sea level rise. And here you can see the entire wastewater treatment plant is impacted. The whole causeway is underwater. Major parts of, let's see, I think I have Machias Part, yeah. The yellow roads are cut off, so they're not even flooded, but during the flood period, they'd be cut off. And anywhere you have these low-lying, bad little culverts and perch culverts and so forth, you have, not only do you have vulnerable fish passage and fish habitat, but you also have vulnerable transportation infrastructure. So you start to see where there's an overlap of the concerns, of the conservation concerns with the municipal and transportation concerns. Also, anywhere where you have hardened shore or where you've had wetlands and coastal forests removed, you have greater potential for more energy to be dissipated onto the roadways that are flooded, making it more likely that they'll be damaged by the flood. And so when the flood waters recede, you still can't get to the elderly people living in those old houses with no power. And so again, you have again the conservation concerns overlapping with the concerns of the of folks in the municipalities. This is another very particularly vulnerable place. This is Jonesport and Beals, and you can see this is Category 2 high tide, so a little larger impact, but you can see a lot of working waterfront infrastructure would be impacted, and that would impact the that would not only impact the town infrastructure, but the fishery, which is very strong. Most of these boats are lobster boats and related boats in here. That would be important. There's a couple of lobster piers also that would be impacted. So all of this stuff is now on our server, and when it's up, it works great. And we are able to add information that can be useful and recombined with other information. So if you're looking at places, for potential conserved lands, you can overlay this with parcel databases and understand values and see, the extent of floods and potential frequency of floods, et cetera. And we are combining that with shoreline zoning data and not only just the shapes of the parcels, but data about the parcels themselves. And then finally, another key piece is the ability to look at this in 3D. So we've been working with Esri, the company that makes ArcGIS, and a Maine company called Blue Marble Geographics to do 3D visualizations with that LiDAR data. So overlaying and then running scenarios so we can sit down with a group of people and say, okay, well, what is this particular park or that particular roadway going to look like under these various conditions? And we can flood it, and when you do it with kids, they always make it like a 180-foot flood. It's really fun. And so then the university is just at the top of a little island. Going forward, we've begun a process of mapping culverts, or essentially planning to map and looking at mapping culverts. And that's a really important element of what we want to do going forward, because it's important for so many different reasons, for fish passage, for other types of stream habitat, as well as the transportation infrastructure. So it's low-hanging fruit in many ways, although it's costly. But we want to, moving forward, look at setting priorities that take both into consideration. And we already have some funding in place for doing some of the culvert work, looking more at working waterfront infrastructure and how much of that might need to move or change or become something different or be reinforced. And we're also looking at harbor management plans, which incorporates not only how public access and mooring fields and so forth, but also how wetlands and coastal forests are managed, et cetera. So, and that's it. So one more, let me just repeat the website, GRO-WA.org is where you can find the output from all the work. And hopefully we have a minute or two for questions.
Thank you so much. We do have time for a question or two. Yes.
I don't know if this gets into what you've been looking at, but there's an opportunity for this to be used really practically right now. So the owners of Helen's, I mean, does the information get to them that they should be preparing for this?
Yeah, I got on the phone to Judy East at the Washington County Council of Governments. I'm like, okay, it's really sad that Helen's burned down, but are they rebuilding? And it turns out that their insurance company's requiring them to build flood standards. They're in the floodplain, and it was a very building that burned down, so they were grandfathered. And you know that brings up a really important issue, which is, what do you do as a little tiny coastal town? It's not really a viable strategy like they're doing in areas of southern Maine, where they're literally saying, you know, some buildings are being required to be lifted up, like they are making them retrofit buildings. That's not practical in Downeast, Maine. So finding strategies that allow, you know, buildings to stand, but when you rebuild, you build to flood standards is really critical. And also asking and answering the hard questions. This is a really important role for conservation, is where don't you build, right? Where is no longer buildable or won't be soon? So that's a really interesting, don't get me started.
One last quick question.
So actually, it's a follow-up to your your answer to the last question. But anyway, has Helen's been ignoring your warnings, or are they doing anything different?
They're building to flood standards, but not because we told them. I mean, it was already in the floodplain, and it floods. I've seen that property with water lapping at their edge of the building before it burned down. So, they're building higher, and it's essentially going to be on a little bunker, I'm told. So,
Wonderful. Thank you so much, Tora.
and I'm happy to answer more questions if anybody has them.